Alright, this is your basic video on forces. In the most simplest way, a force can be considered as a push or pull on an object. It can cause motion, though it doesn't have to. And we measure force in newtons. 1 Newton is the same as 1 kilogram meter per second squared. And an important thing is that force does have direction, which means forces are vectors. Okay, so they have direction and magnitude. A net force is the sum of all the forces on an object. For example, if you guys have ever been canoeing, this guy is pushing with a 90 Newton force, and this guy is pushing with a 70 Newton force, and they're pushing in the same direction. So the net force would just be the sum of those forces, which would happen to be 160 newtons for this picture, because they're in the same direction. If we're in the same direction, like I just said, we just add the forces together, and the net force would be in that direction. If we have opposing directions and the forces are unbalanced, for example, the lady is pushing harder than the gentleman, so that means when they're unbalanced forces, the net force is going to be in the direction of the larger force. Okay? Unbalanced forces in opposite directions, since they are vectors, think of the right as positive and the left as negative. And the box will move in the direction of the net force. Okay? If we have opposing direction, but the forces are balanced. Okay, so we have the force pushing to the left, Rapunzel pushing to the right, or pulling to the right. If equal forces, the net force is 0 newtons. There is no movement of the object. I do also want to clarify, if there's no net force, it doesn't necessarily mean that the object is at rest. It could also mean that the object is moving at a constant rate. So just keep that in mind also. If, for example, we have a large tractor pulling some random box and then a smaller tractor pulling the same random box in opposite directions, the large tractor is pulling with a much larger force, and notice that it's negative 400 newtons because it is to the left, positive 200 newtons to the right. The net force is going to be negative 200 newtons. So negative 200 newtons implies that the net force is to the right. And I do apologize, I should have had the subscript net right here, so that we are aware that is the net force happening on this random box. Friction is a force, and it opposes motion of two surfaces that are touching. There are different amounts of frictions dependent on the surfaces. Just think about when you're at home walking on carpet versus walking on tile in socks or whatever happens to be the case. There's different amounts of friction, which leads to different forces of friction. But friction does have a force, and it opposes motion. So if the motion is going towards the left, friction would be towards the right. Okay. Next little bit is going to be on Newton's laws of motions. I know you guys have heard of Sir Isaac Newton. Famous dude back in the 18th century, did lots of work for the science field, including studying motion. Newton's first law of motion is an object at rest tends to stay at rest, or an object in motion, if it's at constant velocity, stays in motion unless acted on by a force. This is also known as the law of inertia. Inertia is the tendency of an object to resist change in motion. Okay? So again, if something is at rest, it's gonna stay at rest until some force is acting on it. If something is moving at a constant velocity, it's gonna stay that way until some force opposes it. And then inertia, if we look at this, golf ball versus a ping pong, more mass is more inertia because there's a greater force needed to change the motion. There's a greater force needed to get this golf ball to move versus getting this ping pong to move. Even though they're about the same size, the golf ball is going to be heavier. In the same breath, it's going to take more force to stop the golf ball than it is to stop the ping pong. Think of like when you're trying to catch the two. Golf ball is going to hurt more than the ping pong if it's thrown at the same velocity. Newton's second law of motion compares masses and accelerations with those forces. So, for example, say we have a ball that's being thrown at a baseball being thrown at a smaller acceleration by like just playing at the park versus a professional baseball player. The professional baseball player, there's going to be much more force here than there is going to be here. We can also compare like a softball and a baseball. Softballs are much heavier and larger than baseballs. And so even if we apply the same force, which in this case, I know it's hard to see in the picture, but it's like 30 newtons, I think. But the acceleration of those balls are going to be different because the softball is heavier, the acceleration is going to be smaller. Okay, so they're opposite, which means they have this relationship. The actual equation is that the acceleration is equal to the net force divided by the mass, or A equals F over M, but we more commonly see it as force equals mass times acceleration, or F equals ma. And again, I apologize, this should say net force. Okay, so the sum of all the forces that's acting on an object. For example, if we say what resultant force will give a 3 kilogram mass and acceleration of 4 meters per second squared. We pull out our handy-dandy equation, force equals mass times acceleration. I have a mass, 3 kilograms. I have an acceleration, 4 meters per second squared. To figure out that force, to plug in my numbers, force equals 3 times 4, which means the force is equal to 12 newtons. We use a capital N for the unit newtons. A second example says a 40 Newton resultant force causes a block to accelerate at 5 meters per second squared. What is the mass? Go back to our handy-dandy equation, force equals mass times acceleration, except this time we're looking for the mass, so I need to get mass by itself. Since mass is multiplying by acceleration, I need to divide by acceleration on both sides. So I'm going to have force divided by acceleration is equal to mass. My force is 40 newtons. My acceleration was 5 meters per second squared. So my mass is going to be 8 kilograms. Mass is the amount of matter an object contains. This is comparing weight versus mass. Weight is the force an object applies as gravity pulls downward. So since weight is a force, that means it is measured in newtons. Okay? So if you notice, these are very, very similar because we know gravity, the little g, 9.81, is a measure of the acceleration due to gravity. So when we multiply mass times gravity, that is a weight. Mass times acceleration is a force. Therefore, weight is a force, the force of gravity. Newton's third law of motion is probably the most challenging one people struggle with. The most basic definition would be for every action there's an equal and opposite reaction. More correctly would be to say that forces come in pairs, and that object A is pushing on object B, then object B is also pushing on object A with the same force but in the opposite direction. Okay? So this guy is pulling on the wall with 500 newtons of force, which means that the wall is also pulling back with 500 newtons of force. We also have the reaction force from the floor, like if we're just sitting on the floor. Snoopy's weight, his mass times the acceleration due to gravity, so the force of gravity, his weight, is going to be opposed by the force from the floor. He's not falling through the floor, so these have to be equal and opposite. Now the question is, how does anything happen if we have all these forces that are equal and opposite? For example, this lady is pushing on the box with a 30 Newton force, and so the box is pushing back on her with a 30 Newton force. But what we have to remember is when we're talking about motion and objects, is that we're looking at the forces on one object. But when we have the equal and opposite, according to Newton's third law, those are on different objects. For example, the lady pushing on the box with 30 newtons of force the box is pushing back on her with 30 newtons of force, but she has this friction on the floor that is equal to 30 newtons. So her net force is 0, whereas the sliding friction between the box and the floor is only 10 newtons. So there is a net force on this box. So we have to remember that even though we have equal and opposite, they're going to be on two different objects. And when we're looking at motion, we have to look at one object's forces.